The next section is 11.4, geometric series. Now, geometric, obviously multiplying or dividing to get to the next number. And a series is the addition of all terms, or the sum. We have a couple equations here. Again, we have a choice based on what's given. The first equation is the sum is the first term minus the first term times r to the n power, all divided by 1 minus r. Or, if we're not given, well, actually, this one is just a variation of that one, where we actually factor out a sub 1 and have 1 minus r to the n divided by 1 minus r. So it's just a simplified version of that. We may have to use the geometric sequence formula, which we've talked about before. Here it is right here, in order to find term numbers or common ratios, something that's not given in the problem. Let's say, for example, we want to know the sum of a geometric series where the first term is 15,625. A term, we don't know what term, is -5, and the common ratio is -1/5. So obviously we start very high and we get smaller and smaller, alternating between negative and positive because our common ratio is negative. We're going to use this formula here, and we're going to solve for, actually what's going on is we're going to introduce an alternative sum formula, and this is it. This is a new formula. It's derived from one of these based on the given information. And it's a much simpler form where we don't have to actually use the term number. So in this geometric sequence, we know what term number we're on. And in the arithmetic series, we actually found the term number to plug in. But this formula here, since we're given the first and a term number, we can just plug those in. So this is a handy formula. We're going to plug in 15,625. We're going to subtract -5 times -1/5, and we're going to divide it by 1 minus -1/5. When we do all that math, we end up with 15,624, because those two cancel and we're actually just subtracting 1. Divided by 1 minus a negative is plus 6/5. If we mark that up in our calculator, we get 13,020. That would actually be the sum of this entire sequence. If we had, here's another example, if we had the actual sum, which is 39,360. Our common ratio is 3, so we're multiplying each time. The 8th term is this. We want to find out what the first term is. So we're going to plug everything into the equation that we know, and we're going to solve for a sub 1. I'm going to use this equation right here. In this case, n is going to equal 8. So given this equation here, we have the sum, which is 39,360, equals the first term, which we don't know, times 1 minus 3 to the 8th power divided by 1 minus 3. When we do some simplifying, especially this part here, and obviously 1 minus 3 is negative 2, we're going to come up here, and our sum equals a sub 1 times negative 6,560, all divided by negative 2. We can multiply both sides by negative 2, divide by negative 6,560, end up that the first term is 12. Most of the time these are going to come up pretty even.